Right, so I'm just going to explain how to solve this system of equations when there are three variables and just go through the process that you should be following each time. So you can see here we've got three equations. So as always, just number them, 1, 2, and 3. And then before you even start doing anything, just have a look at it and just see if there's anything that leaps out. And hopefully what you spot in this case is that those two planes there have their coefficients all in the same proportion. You can see like that's a 1 to 1 to 3 proportion, and that's a 1 to 1 to 3. So we know straight away those two planes are parallel. And notice, or the reason I know they're parallel, sorry, is because you can see the constants are not in that same proportion. So if they were going to be the same plane, this would have to be, say, 20. So we know, therefore, they're likely to be parallel. We just have to verify that with algebra. So what we do is we create, in this case, a fourth equation, and just use the notation from above, 1, 2, and 3. So I know that if I take equation 3 and I subtract 2 lots of equation 2, that's going to give me 0 x's, 0 y's, 0 z's, so nothing on that side, and it equals 8. So that's a false statement. So if statements are false, it means that whatever you're comparing are parallel. So in this case, I would say planes 2 and 3 are parallel. All right, so straight away we've got the situation where the two planes can be looking a bit like that. Then what I need to do is find out, well, what's the third plane doing? Is the third plane parallel also, like so, or does it cut through them like that? So the way to do that is then to combine equation 1 or plane 1 with one of the other ones. So in this case here, I might say, well, what I can do is I can eliminate the z's pretty easily. So I could say equation 1 minus 2 lots of equation 2. And I'll get a negative x, negative 10, also minus 6y. The z's are gone. And negative 6 minus 20, negative 26. Which we could, if you wanted to, you could turn into a nicer looking line, but it doesn't really matter. But you see there is a line of intersection. So there is a line of intersection between planes, what have we got there, 1 and 2. So we would need to state that. So between planes 1 and 2. So therefore, we know we have this situation here. Now, because we have planes that are parallel, obviously they meet there and there across that cross plane. So what that means is, therefore, there is no unique solution. Actually, no solution at all, because there's no point or points where all three planes meet. So it's really important you go through that process and visualize what's happening at all times.